conversation, we would then composite.
This is an exciting panel to me because this has been my life for the last 2-3 years. By the way, if you didn't notice, that was all live using broadcast technologies like ST2110, SRT. So that was awesome.
Cloud and on-prem.
And yeah, using cloud to connect the signals. So that was awesome. So thanks everybody for hopping on. This is a great panel. So quick introduction. So my name is Pete Thordarson. We have Casper, Sam, Ryan, and Gary. You guys can look them up. We have a lot of content to cover, so introductions are gonna not happen today. So first of all, I do have a question. So keeping on topic, what has improved in the last year or two with ST2110 adoption? What are you guys seeing that has improved? Maybe we talk about a little bit of things that need improvement. Happy to, kind of start that engagement. So let's just throw it out there because we've kind of all talked about it a little bit. Where's NMOS today? And feel free, anybody to start.
Well, I know we've come quite a long ways in the couple past years. We've gone through interop testing just for basic signal interoperability, but control is always key. So some of the major advancements really are bringing us to that open standards ecosystem that allows plug and play of devices. Now we're not fully there, but a good approach could be we're nearly there. We're right on that cusp to where I can take a device, plug it in, I discovered over 04, control it over 05, and things are starting to become a little more magical.
Yeah, and over in the last 6 months or so, there was a resuming of the JTNM interop testing, where there were a lot of vendors that got together. I think it was in Wuppertal, and we're just testing out ISO 4, ISO 5, SMPTE 2110 applications, and there was a growth in the number of vendors participating. So not just your really large ones that are very common in all essentially all SMPTE 2110 deployments, but new players in the game as well, which is it's really encouraging to see more folks getting involved with these sorts of interops.
Yeah, I think that SMPTE 2110 came a long way. So like you said, right? Like in terms of video audio operability, we're making real steps. SMPTE has done a good update also recently, but it will take some time, of course, for the vendors to implement that as well. But there's still a lot to gain on the control monitoring domain. And I think, if we go, NMOS is good, but having API access to every single element that is part of the setup and having a control system and then a monitoring system deal with that, because it's all software, and software developers like APIs, and instead of putting something in between might be the solution going forward.
Who's that on? Is that on the manufacturer to develop those APIs or the customer?
I think it's both. The manufacturer will essentially do what the customers need, right? So I think it's both, and I think that there's a world for both, because you have infrastructures that are less advanced that could deal with certain elements of control, whereas you have more advanced infrastructures where you need potentially every single element that's available inside of a piece of kit, piece of software, piece of network.
Gary, what's been your anecdotal experience with NMOS registration, plugging things in, showing up, not showing up? What have you guys come across?
What we've seen is most devices appear in our topology. We see a lot of the devices, but how that information, how that JSON is passed, and how the discovery server sees that. We've had, I think Sam was involved in this, interfaces that were kind of reversed, which it appeared that the service was working, but we weren't getting any output. So I don't know if that's how that script is written and how it's passed over. I've seen some similar issues with other tech like this, Arista is one where if you're going to be putting out a version 2, is everybody sticking with the rules around version 2? And we're seeing a disconnect in there.
Okay.
So that's been an issue.
Well, Gary, that's just it. The expectation has always been, I can go out and find any product device that conforms to standards. That's what 2110 was all about, and that's the beauty of it. But you're still beholden to control systems and how they interpret that data. Despite the way we transport the signals may be standardized, NMOS does have a framework, but there are subtle differences in how that's interpreted. So back to you, Casper, with a common API that's exposed, we're used to that. It's RESTful in nature, it's easily readable, but fundamentally, you still run into very subtle interop issues. Just like you said, it could be backwards interfaces. It could be a flag set to true or false that might not expose 4 branches of audio or just one. Just little subtleties like that. So I think we've seen many, many major improvements in that, but we still got just a little bit to go.
All I would add is, over the first 5 years of, SMPTE, of 2110 being out, and because I think there was a thought or a question around, going forward, how do we see that going forward? I mean, there's a lot of progress made in that short period of time.
Yeah.
So I think that's a very positive thing.
Mm-hmm.
And I see most of the deployments I'm working on these days, most of the SMPTE 2110 applications, there is an ISO 4, ISO 5 component to it, but it's not universal throughout the entire topology, throughout the entire control mechanism, because like what Sam was mentioning and Casper and Gary, there might be some compatibility issues, but there also might be performance hiccups as well, where each vendor's native API might have better routing performance, which everyone always aims for, getting the routing as quickly as possible so it resembles SDI as much as possible. So I'm seeing a really healthy mix of, while ISO 4, ISO 5, just NMOS is present in the majority of the 2110 deployments, it's not just that, it's also the native APIs as well.
So interop, Fox hosting a lot of interop testing 5 years ago at the Woodlands. How have you all encountered today's version of what Fox was doing back then to better support interoperability between manufacturers? Is that happening today? Is everybody doing their own island interop testing in their own labs? How are we talking to each other today, I guess physically? Are we going to a location like the Woodlands? I don't know if anybody is in here from Disney, but what's happening today? I'd love to hear you guys' thoughts on that.
We are doing a lot of interop testing in our labs. So with the vendors also, we have deep conversations with all the vendors involved to improve the capabilities that we can get out of their gear. But to your point, right, are we doing that as an industry? I'm wondering, and I think we should, because we all will advance more, and there's only limited capacity of engineers also that can help us move the needle going forward. But I think, like also for us, like our customers drive what we need to do. So our customers define what the roadmap will look like for the interoperability testing and the advancements in technology and control, for that matter, going forward.
Well, I think it's almost twofold also. You do have JT&M carrying the torch, and we've been, attending events for many years on end, but the fact of the matter is, when you're trying to build your own facility, you're still going to duplicate that effort, and you're going to be involved directly with the manufacturers, the vendors, the integrators, to truly prove it. Despite we could have proof on paper, but I want to actually see how that interoperates with one another. Take a concept that we're all very familiar with, a salvo. I press a button and I fire just tons and tons of rounds in, 1 second. You've been used to a certain way that salvo is switched, and you expect your baseband router to switch those cross points, and it could be a benchmark of 50 routes in a frame. But you have different devices at the edge that may interpret those commands a little bit differently. It could be an ISO 5 command, it could be a native API, but you might have subtle differences there. So still coming together along with JT&M and internally to drive those topics forward, we have to continue doing that just to make sure things truly are the best of breed for problems we're trying to solve.
I think you're spot on, right? Like, there's no way we would take a piece of equipment and just put it in production without
Exactly. Yeah.
completely taking it through.
It's like, how will this behave under my circumstances, the way I'm going to bang on it and treat it? It's like, I have to see with my own eyes and see the actual proof. So, yeah.
Yeah, no, I see those as well. You know, obviously the JTNM I think is a very big deal just because it does bring everybody together who wants to participate. So again, like over 70 vendors or so. But I do see a lot of these companies as well holding, you know, extended length POCs, for example, bringing in everybody's vendors together to really look at all the vendors together to really find that best in breed, which is obviously the goal here with this, you know, with the various forms of standardization.
Yeah, what came out of the Woodlands was incredible. I mean, I wasn't privy to being there, but I heard stories and it was awesome. So hopefully we can continue that. Taking a step back, so I'd love to talk about like the theme of today, or at least half of today, is ST2110. This is a bigger overarching question, but why and who? So in other words, if you're a corporate company that has worldwide offices, where does 2110 pick up where SDI fell off? And who are the typical customers you guys are seeing deploy? Maybe not the big networks, maybe not the NEPs, but maybe the smaller folks or mid-sized companies. I'd love to and open that up to anybody.
Well, to kind of kick that answer off, take a look at campus environments. Could be let's say one geographical location, not spread out across the globe, but take a venue, and I have centralized production, you know, RIMI models, things like that. Step back 10 years, I'm dragging individual fiber, maybe fiber muxing, and then I'm passing signals back and forth. When you start moving into the 2110 environment, now I'm not really beholden exactly to where those drops are. I could build a fly pack, and I could go drag that anywhere to cover any type of production on that campus. But then you can start scaling it out that much more. So it becomes a more versatile solution. So going back to Gary and the LinkedIn deployment, spot on. You're geographically separated, you're building WAN environments, and you're dropping in equipment or software-defined services to do what you need to do, and it becomes actually attainable to do that. Whereas in the past, it was a lot of heavy coax, a lot of heavy fiber. Now I'm decreasing those counts and really making it that much more agile to do.
We're also thinking about taking it a step further with what's coming soon, which is IPMX, and including our UC teams. So we're on a big campus, and we're the tech company, and what do we have? We have cafes and breakout rooms and all sorts of things that have monitors that are spread all over the place that are showing content. And today, a lot of that is being done with the digital signage model. But if we have a media network, doesn't necessarily only have to support production. IPMX would be compatible and be able to operate on the same media network. Well, now we have centralized a lot of the content and the tech, and then now distribute out to all of these displays. And because you have the advantages of Dash 30, you can be sending your audio to a DSP that's providing audio in all of those locations and the video to the displays. And you have a really good control over all of that from a central routing system. So that's kind of our next.
Yeah, I would also say to that before we were building infrastructures with cables that the size of the router or the size of the system is the size of what you can do, essentially, right? And it's there's still value in it because it's easy. Everybody can understand. If you plug a cable, it either works or it doesn't. Yeah. And with a network topology, that's very different. Issues are different. Issues are more advanced. However, the beauty that comes with it is audio is not a thing anymore, right? Like before you had whatever is on the panel, that's the limit of your audio. Right now, it's not. It's just another plug on the network, and you have all your audio available, as well as if you want to route a signal to a certain location on a campus, and you want to route a video signal with certain audio signals, you don't need to get it through a process. You can just do that at the edge on where the signal needs to go to. And those type of things were not possible in the baseband world.
And also, oh, pardon me.
Sorry, with NEP in the World Cup, not a campus scenario, but not dissimilar to a campus architecture. Would you mind touching on a little bit about how that went?
Yeah, I mean, I think biggest element in any deployment, for that matter, is if you have interoperability between different vendors that are providing services, like some of the major events that we are doing. It's not all NEP. We dream of it being all NEP, but it will never happen, right? But what comes in place is, what's really important is the security handoff between every single vendor that plays a role on the network. So having that control, having that capability of making clear demarcation points and then controlling those clear demarcation points and putting true security on those true demarcation point makes the difference. And that's some of the work that we are really focused on in terms of building our product called TFC, is having that software-defined networking capability, taking away some of the complexities of creating, large-scale network infrastructures, and having the ability to have multiple service providers provide their services in one cohesive system. That's our focus.
And we touched on security. The topic is advancements. How are we advancing our dialogue with our security teams and the IT departments on ensuring we're compliant, devices are not going rogue? I'd love to hear just a bit from each of you on some of your experiences on advancements or areas that we need to work on as an industry.
You want to go first?
No, sure. Yeah, no, I think this is getting more common now for there to be, more security measures taken. Previously, SMPTE 2110 networks, as an example, were more, they were more closed off.
Yep.
I think, but now folks are seeing that, if the entire network obviously is one giant network, so there might be more points of entry. So there are definitely solutions out there, for like network detection and response, which can prevent bad actors from getting into the network and overrunning it or locking some of your file storage content. And we're seeing more companies now take that seriously. And also just very basic things like disable telnet, have like a TACAX or radius server for all of your authentication, only supporting SSH, having real passwords, not password as a password, for example. I still do see that, believe it or not. So this is, it is taking a more, there's a more cautious approach now, and we are working with internally with at Arista at least, on introducing some of our kind of NDR solutions into these systems to make it more safe.
Yeah, as I said before, it's like one of the elements is having true control, right? Like having true control over your network, making sure that your SDN functions the way you want it to function is one thing, but control is not everything. It's like you need monitoring, proper monitoring. You need automation techniques and build capabilities in the form of, security goes in multiple ways, right? One is you want to secure your network to make sure that you don't have bad actors on the network. So that requires monitoring, but it also requires automation in order to bring those bad actors into kind of demilitarized zones, right? But also in terms of, we cannot miss one frame in live production. If camera one is on one of our games and it's actual, losing one frame or actually losing one packet means we have a problem. And making sure that you have that monitoring in place, making sure that you have that redundancy across your network in place in order to not lose a packet and therefore have a hit on live television is super important.
Yeah. But it also comes down to who does what. So early days, it was more network layer. So I drop a layer 2 network in, it's isolated, and much like you said, Ryan, now it's just one large network. So not only are you trying to do away with the bad actors from an edge device perspective, but who, from a control system perspective, can actually get in there and do something to the system. So you're thinking more outside of the box, not just the network, not just these devices. I want to make sure I'm tying into my Active Directory. I'm only giving access to certain individuals to get into that control system, because that's that very top layer. You've got visibility into your network, your edge devices, how I control things, how I monitor the ecosystem. Incredibly important. So it's getting much, much better.
Especially as, our core facilities are decentralized nowadays, and maybe we're putting some of those control and monitoring systems in the cloud. And they're, at the very least, we can monitor things, but in many cases we can control things. And cloud is accessible to everybody.
I agree, right? I mean, so also you go over third-party networks all the time.
Right.
Like when we started building our platform down in Australia in 2017, that was the biggest issue. It's like, going over third-party networks, you don't know what happens along the way, because it's kind of like you put feeds in and they come out the other side, but it goes through all kinds of hubs, et cetera, that you don't have visibility on. So making sure that you measure the in point, out point, and being able to manage your network through automation is key.
So one of the things that I kept on asking myself in the last couple of years going through this process is, okay, this is fine, we're Microsoft, we have the budgets, we have the desire to provide the best architecture, to provide the best storytelling to our company. Not everybody has those resources. So looking ahead for the next couple of years, how do you guys see the democratization? And I'm using that term kind of like in the sense of, I'm not saying you can go out and spend, $1,000 on a router and be off and running, but when do the smaller to mid-sized facilities, when do we start seeing them adopt some systems in a 2110 environment on their existing networks? And maybe it's Arista, maybe it's Cisco, maybe it's Netgear. What are we doing as an industry to create a wider adoption of 2110?
So, we're, at least, with Arista, we are working with our broadcast vendors to come up with more turnkey solutions. So folks will be able to take advantage of the, the benefits of SMPTE 2110, like the scale-out solution, all the scale-out, whether it's a spine leaf or a more monolithic kind of approach. But given the advancements in, merchant silicon, where the chips are doing more with less. Now now we have boxes that are like 1 RU with 32 interfaces of 800 gigs. So, that's a serious amount of bandwidth, a serious amount of scalability. But working with the broadcast control vendors or our broadcast vendors to create these sort of turnkey solutions, so a smaller or medium-sized customer might be able to go up to this broadcast control and say, I want a router that's 1152 by 1152. And that could easily be deployed with taking advantage of IP without a lot of the complexities, I think.
So putting more of the power in the tools and
exactly.
the control systems.
Exactly, and working with these guys to come up with, as Casper was saying, automation techniques.
Yep.
So once the system is up and running, you'll say, I want an 1152 by 1152 router. System gets deployed, maybe they just have to hit up, get the switches online, hit a button, and all the configs just get beamed down to the switches based off of the customer's requirements. I think that's, that's where, no, I don't even want to say that's where we're headed, that's where we are right now. Okay. I just think it needs a bit more, customers need to look into these more turnkey solutions more.
I would also say, look at the evolution that we just went through, right? Like we came from closed setups with baseband infrastructures that were, you can do whatever is in the infrastructure. Then we went to transitioning that into an IP infrastructure where 2110 is now key, right? Like it's fully adopted in our industry. But the next step in my eyes is we're going to now connect all our infrastructures together and share resources, share production feeds, share everything. And that's a whole new world, effectively. Like we've never done that before. As an industry, working together, sharing the resources, sharing potentially even the engineers, and then sharing the equipment or software going forward out of the cloud is what I think is the next big thing that's going to happen to our industry.
Yeah, that's exciting.
Well, democratization was a very key word that you mentioned. So when you look at industry events like JT&M, when that all started, you're having the big players. And then slowly it's kind of letting others in. And these days it's, now I just have commercial off-the-shelf equipment, a couple of network interface cards, and I want to play in the big sandbox with everyone else. I want to make sure my things work. So now you have more options on the market to really find what is that product or platform that is plugging a hole in my workflows. And it's compatible, we know it works, it's been tested, and so you're getting to that point to where it becomes easier and easier to deploy these routing systems. And just like you said, Ryan, I need a 1152 squared router. Well, great. I've got a core in the middle, edge devices with interfaces, and then connectivity. And then I should be able to press that button, automate what it does, and then boom, I'm ready to go, I'm off to the races. That's where we're going to, and that can solve the needs for not only the major players, but you have also the smaller ones that might not need that giant workflow. It's more of a smaller scale, but it's easier to manage, easier to deploy. Day-to-day operations become that much simpler to do.
And that's a good, so I'd love to hear just anecdotally from you, like I just asked you a few minutes ago, I said, so your NV9000 controller's gone. You're like, gone. Like it's you know, you're on the new system. How was that transition? How did that go? What would you do differently?
The transition went well.
Okay.
And I'm happy that we did it. In the timeline of things, we actually had to skirt through Convergent, which was another platform that was pretty much deprecated, and Orbit became the controller. But from the operator's perspective, everything was working the same. For, you know, how the engineers had to configure that system and make all of that work was a bit different. And you know, when I think about the question, how is this going to democratize over X period of time? I think some of the ideas that I've heard here are great. There is a big reliance on software, and you know, there is no such thing as version 1 forever. So there's constant revs and there's constant bugs that you find in all of this, and you know, anybody that's looking to kind of put their big toe into this environment should, in my view, really have a reason to do it and not do it just for the sake. When we talk multi-campus, we talk buildings that are various areas, and being able to drop leaf switches and all these various and have it run under. I mean, if you have a use case like that, 2110 is a perfect way of approaching that. If you're just in a single building with one control room and a studio, maybe not. Maybe it's not worth all of that, because the talent that's needed to be able to run, operate, troubleshoot, we're finding some great people. Found a great person right there in Tim, but that is a struggle that I've seen. So there's a lot to it.
So last question, great segue. People. And in many conferences in the past for the last number of years, that's been a major concern. It was a concern for us at Microsoft. You know, it's the IT versus the broadcast engineer. How do we create this unicorn, this crossbreed of, you know, engagement on both sides? How are, just kind of a bit of a rapid fire question, couple of, like we're almost at time, but are you guys feeling good about the state of the engineer today, the IT and the broadcast, or how have we been seeing their adoption on learning, on, you know, keeping the place on air? Love to hear just a quick.
I'll say something really quick, which was what I've seen, certainly in the early days, things have been improving, was network engineers that have experience with the kind of roots of what's happening on a network switch, and they somewhat think that can apply to everything, and they take what is really required on a broadcast system. And those were very hard conversations to have. It was, you know, how do you prove it? Okay, well, I'll wait till my system crashes and then you can see, but we can't allow that to happen. So our dialogue has been really good. I'm happy with and love our global network team. They've really come on board and do a lot of good work for us, but that did take time.
I think there's, you know, generally, I don't think there could ever be enough training. And we're working on developing training for broadcast and network engineers alike on ideas that are very important to SMPTE 2110, like PTP, like multicast, which are kind of unique really to broadcast. So working on those forms of training, getting people familiar via POCs with troubleshooting these sorts of systems, and as Casper mentioned also just earlier, just getting the right kind of monitoring, getting a broadcast monitoring, getting network monitoring, and kind of being able to get the same information in some way in both, so that the broadcast engineers and the network engineers can talk the same language. Yep. Network engineers might say, hey, I want to know what 239.111 is, but broadcast engineer might be saying, I have a problem with camera 1. Getting that kind of common language so that, and event-driven monitoring notifications as well.
And again, going back to those tools, the notification systems, and that's I think the magic part of this whole thing. And as we, going back to the API conversation, which again, not everybody has the team to help develop it, but more as the industry starts to develop better tools for a facility to work with the systems integration companies, the local staff, I think we'll be better off. So thanks everybody for the panel. Appreciate it.
Thank you.
Thank you.